Transactions are a fundamental part of blockchain. They are traditionally transfers of value between accounts. Now, before we dive deep into transactions, let's consider the platforms that they're running on. On the left-hand side, you have the largest platform today, the World Wide Web, through which most applications are delivered. And on the right-hand side, you have the blockchain network, a series of peer-to-peer nodes distributed throughout the world. Now, one of the things that might be going through your mind is, how are we going to bring these two together? Ideally, you'd like the reach of the web, and you'd like some of the convenient properties of blockchain. And that's very much what we're going to do. We're going to deliver through a web page on a browser a plugin called MetaMask that itself connects back to a node that participates on the blockchain network. So as you can see here, we have the convenience of a web browser. We have the light client, which is a web page. And at the same time, we're holding a connection to a node on the blockchain network that allows us to perform transactions without having to have a full node on our desktop, without having to make that replication of hundreds of gigabytes and having a dedicated machine. For the purposes of demonstration, I have created a couple of accounts on blockchain. You can see here that if I click on this button, you'll see that I have an account called Alice and I have an account called Bob. Now, it's worth mentioning that these are just cosmetic names. The actual address of the account is the long one you see here before you, and you can copy it to the clipboard, and we will do that in a minute. Now, the other thing to note as well is that this is a brand new account. It has no funds. It has no transactions. Now, we can navigate to Etherscan, a service that allows us to see all of the data in the blockchain network through a web front end. Now, if you were to create a node that joined the blockchain network, you'd get a copy of all of that data. However, that would be quite a big chore to do. You'd have to dedicate a machine. You'd have to figure out some convenient way of navigating that information. In this case, this node that participates fully within the blockchain network, it's currently synchronizing its data and allows you to see and navigate the data that exists within it. So in this case, we can look at the details of Alice. And if I click on it, you can see here, I can view the Etherscan data. And this is connecting to this special node that allows us to browse the information of this node. And as you can see here, it's pretty boring. Nothing has happened. It has a balance of 0 Ether, and it has no transactions. Now, the next thing that we're going to do is that we're going to transfer some funds to Alice to demonstrate how that can be done. I'm going to do that in a separate machine, and I will connect to that next. As you can see here, I'm bringing in an external browser, and I'm going to go ahead and expand the MetaMask information. And as you can see here, I have a pretty wealthy account. It's worth remembering that this is a test network. It's not real Ether. Otherwise, that would be significant funds. But I'm going to go ahead and transfer some Ether from this account, from Abel, to Alice. And what I need to do in order to do that, the very first thing I need to do is I need to copy that address that I mentioned. And now I'm going to go ahead and begin or to start a transaction. And so I'm going to go ahead and send some money. I'm going to paste the address that I just copied. I'm then going to enter here 5 Ether, which is what I'm going to send. I'm going to confirm that transfer, and we should see it momentarily show up on our account. So I'm going to move this out of the way for now. So as you can see there, we just saw the 5 Ether come in. We can go ahead and navigate to the details on Etherscan. Could have just reloaded the other page, but as you can see here, 28 seconds ago, we received 5 Ether, and it shows the account that it came from. It shows the account that it was going to, which is Alice's account. And this is now open, browsable by anybody on the network. And there's a few things that I'd like to call out. First, there's a transaction hash, and it has been mined into a block. If we were to go into the block, we could see the details here of that block, and we could even see the number of transactions that were included within that block. So as opposed to the traditional bank, we have here full transparency. We can see all of the transactions that took place. We can inspect the blocks. We can audit the movement of funds between accounts. Now, it's worth noting as well that this is not tied to an identity. This is not tied to a state-issued ID. It is, in fact, just a pair of keys. A private and a public key define your account. So in that sense, we have some privacy, and I'll say more about that towards the end of this lesson. So let's go ahead and go back to our slides. As you can see, we created or we demonstrated that we had a brand new account with no transactions, no history, and no funds. We then navigated and inspected the data for this account on Etherscan, and we saw that it was empty. We then transferred from a rich account that was generous enough to transfer 5 ethers to Alice, and we saw that we could inspect all of the data on blockchain. You can think of each block as a sheet of paper that contains a list of transactions. And as soon as a block is mined, the sheet of paper is finalized. That is, we have validated all of the transaction details on the sheet of paper that are true, and they will no longer change. So now that Alice has some money, we're going to go ahead and demonstrate how she can transfer within her account some funds, 1 Ether to Bob, and we will see what that looks like on MetaMask and also within Etherscan. So within MetaMask, we're going to go ahead and send some funds now that we have some, and we're going to transfer here between accounts. We're going to send an Ether, as mentioned, to Bob. And so I'm going to go ahead and enter the amount here, 1 Ether. I'm going to confirm that next. And I'm going to go ahead and send it. And as you can see, that is pending. If we were to select it and we were to navigate to the Etherscan data, we would see that that would be pending. Typically, we see some type clock. At this point, we don't even see that. You can see there the little bubbles. And we just saw that the transaction has been confirmed. And if we were to reload this page, we should be able to see the transaction. Still not showing up. Let's go ahead, and now it just did. That means it's been mined, it's been added to the blockchain, is now part of the data set that will continue to be part of blockchain forever as long as this blockchain exists. Now, if we go back, let's go ahead and go back to MetaMask and go back to the other account, or sorry, we're still on Alice. And we click on details and we view Etherscan, we'll see here that we have now and that took a second to reload, but now we can see it. And if we see here the transactions on this account, we can see clearly the very first transaction that came in, which was the generous donation of Abel's account onto Alice's. And you can see there that 5 Ether came in. Then the next transaction that took place was the 1 Ether going out to Bob. And you can see there the account numbers. You can also see the blocks that they were mined into. And you could really audit the movement of funds throughout the chain if you needed to do that. And this is why oftentimes it is used for purposes where you want to demonstrate transparency. You want to have all the partners be able to verify the information. Also, when it comes to the IDs, these are not state-issued IDs. These are simply private and public keys that are used for identity, which means that you can use them for populations that do not have these state-issued IDs. You can use them for refugee populations, and there's great examples of the applications of this today in the market. Now, if we go back to MetaMask and we transfer to Bob's account, I'm going to go ahead and do that next. You'll see that Bob has 1 Ether. And if we were to look at the details, once again, on Etherscan for Bob, we would see one single entry. This was a brand new clean account. And the only thing that we have was 3 minutes ago, there was an inbound transaction that transferred from this account number here, which is Alice's, to Bob's, which is the following. And you can see here 0xA7D9. And if we go back here, you'll see here that we have 0xA7D9. And so we can match those accounts simply to verify that we're looking at the information that we expect to be there. Let's go ahead and go back to our slides, and you can see there the operation that we just performed and the confirmation that we made within Etherscan. I'll close by making some comments, and the first one is that identity is done by keys. This is the first system where you can have global agreement, you can have a currency tied to it, and even smart contracts that accompany it. As mentioned before, this did not require state-issued IDs. It does not require a trusted intermediary. And so it's turned out to be a very practical solution in many scenarios. Now, when it comes to banking and other heavily regulated industries, there has to be KYC, and there has to be a lot of other requirements that are brought to the system. But as it was designed and as has operated in the public networks, this is the way it is implemented. The other thing to say as well is that this is an open record as opposed to the financial balances that exist in banks where nobody knows what everybody else has. In this case, everybody can verify everybody else's account, which means that you can confirm if a movement took place. You can also confirm whether funds exist. The other thing to note as well is that there are no trusted intermediaries. That means that banking institutions can be bypassed. That means that many government functions can be as well. And so there's some great opportunities there for efficiencies because of that. We also performed our transactions near real time, and the performance of this is restricted to the performance of the network. If the network was to be heavily overloaded, that might take longer, but if we compared it to cross-border payments, certainly this is lightning fast when it comes to speed. The other thing as well to note is transaction fees. You saw some transaction fees that were taking place. Depending on the load of the network, on the cost of the currency, that can impact price. But in general, that has been minimal. I should also say that through many of these items, there are additional networks. This was demonstrated using the Ethereum blockchain, but there are other blockchains that address some of the shortcomings when it comes, for example, to confidentiality, which I'll mention in a minute. When it comes to privacy, often the privacy of blockchain is called pseudo-private. Others have criticized it by saying that many exploits can be used to discover the identity, but by design, it is meant to be anonymous, although there are some shortcomings. And as I mentioned, other networks address some of these shortcomings. It is also robust in the sense that it's a decentralized system, which means that several geographies could go down, and as long as you had some of the required numbers of participation, you could continue to operate. And lastly, because of what I mentioned when it comes to robustness, when it came to decentralization, there is no place to put a cease and desist letter. There is no place that the police can show up to confiscate the servers. This is distributed in a peer-to-peer fashion throughout the world, and because of it, it is harder to censor. Because of it, it is more robust. That doesn't mean it can't be taken down. It just means that it is more resilient than the hierarchical networks that we have at the moment. So with that, go ahead and give it a try. It's a fun thing to do. You can move around some funds, and you can get a sense for what the properties of blockchain are, how to investigate the data within the network, how to follow transactions, how to discover what's in a block, and so on.